Okay, so just a quick recap for Michaela. Two events are independent.
Or Mountain Mill Lake.
Oh. Two events are independent. If one event does not affect the probability of the other event, and then this is our formula, we just multiply probability of A times probability of B. Okay, let's take a look at this problem. Suppose you roll a red number cube and a blue number cube. What is the probability that you will roll a 3 on the red cube and an even number on the blue cube? So all we're going to do is multiply those two probabilities together. Garrett, what's the probability that you're going to roll a 3 on the red cube? It's just a normal 6-sided cube.
3 out of 7, 1 out of 6.
1 out of 6, good. So we have 1 out of 6 times, what's the probability that you're going to roll an even number on the blue cube? Julia? How many numbers on a normal dice are even?
Sorry.
3, good. So we're going to multiply times 3 out of 6. I'm going to reduce before I multiply, so I'm going to reduce here, change this to 1/2. 1 times 1 is 1. 6 times 2 is 12. So the probability is 1/12. When you multiply fractions together, the fraction gets smaller, so you end up with a smaller probability.
Eat. What is for brother?
Okay, let's take a look at some other examples. Okay, you roll a red number cube and a blue number cube again, normal 6-sided cubes. What is the probability that you roll a 5 on the red cube and a 1 or 2 on the blue cube? Olivia, what's the probability that you're going to roll a 5 on the red cube? How many 5s are on the cube? 1 out of how many total numbers? How many numbers are on a die? 6. So 1 out of 6. What's the probability that you're going to roll a 1 or a 2 on the blue cube? Easy? 2 out of 6, because there's a 1 and a 2. That's 2 choices out of the 6 choices. Again, I'm going to reduce before I multiply. It saves me a lot of work later. 1 times 1 is 1. 6 times 3 is 18. So the probability is 1 out of 18. Okay, next example. Suppose you roll a number cube and flip a coin. What is the probability of rolling a number greater than 2 and flipping heads? Garrett, what's the probability that I'm going to roll a number greater than 2? How many numbers greater than 2 are on the die? 4 out of 6. Olivia, what's the probability that I'm going to flip heads on a coin? How many possibilities are there? Right, there's 1 head out of how many choices? What else could I flip? I could flip heads or tails, so there's only 2 probabilities. I'm going to multiply them together. I'm going to reduce first. Let's see, 2 goes into 4 twice, into 6 3 times. I can also cross simplify on this one. So I get 1/3.
Sounds so official right now.
Class dismissed.
Next example is from a game. Has anyone ever played this game?
No.
I've never played it either, but my 6th period class told me this is Mahjong, and some kids had actually played this before.
Mahjong.
So I'm not really sure how you play. It's spelled like this.
Mahjong. Do you have a dragon or a parrot?
Call me your
All right.
I got a sunflower.
You
I
choose.
kick my teeth.
You choose a tile at random from the game tiles shown. You replace the first tile and then choose again. So after you pick your tile, you're putting it back. So that makes it independent. If you didn't put it back, it would be dependent, but we'll talk about that later. What is the probability that you choose a dotted tile and then a dragon tile?
Ooh, that dragon tile goes.
Julia, what's the probability that you're going to choose a dotted tile?
I'm definitely picking that dragon.
4 out of 15. What are we going to do with these 2 probabilities?
Big Mahjong.
Are we going to add or multiply?
Multiply.
Multiply.
Yeah, 'cause that's our new lesson. Why wouldn't we multiply?
Yep. Alec, what's the probability that you're gonna choose a dragon tile?
3 out of 15.
Okay, times 3 out of 15. I'm gonna reduce,
Whoa, reduce down here.
Oh,
and I
man.
get 4 out of 75. So the chances of
Dang.
doing that aren't very high.
Wait a minute, what the heck? Oh.
I'll take the chances any day.
Okay, next one. What is the probability that you randomly choose a bird and then, after replacing the first tile, a flower? Casey, what's the probability that I'm going to choose a bird?
250s.
Good. And Garrett, how about the flower?
150.
What's that? 115? Can I simplify before I multiply here at all?
No, you cannot. You
Okay,
might
so
as
I end
well
up
not
with
care.
2. What's 15 times 15?
I'll do 75. No, yeah. No, 2
It
times
just threw me off. I was like, it's, I know it's gonna do 100.
No, I played at
75.
15 times 15 up there, and I realized you cross that 5 out after
This
a
is
7.
like 75.
Okay, so we're good. Independent events are pretty easy. Dependent events, there's another step that you have to do in your brain, but it's not that much worse.
Top of the check.
All right, so objective 4, this should actually say objective 3. I skipped a number. Objective 3. 2 events are dependent events if the occurrence of one event affects the probability of the second event. So an example would be selecting something without replacement.
Listen.
It's okay.
Dude, that's when someone was sitting there and we go, what?
Yeah, man.
Something.
Okay, so in the game we were looking at with the tiles, if you picked a tile and you kept it, you didn't put it back, that would make it dependent. The formula is a little bit different. It's probability of A, then B. You're still gonna multiply the probabilities. You're gonna multiply the probability of A times the probability of B after A. Because the probability of the second event is going to be different if the first event already took place. So we have to specify that this is B after A.
Time out. Why did
Look
you
like
put
my mom
that
signs
instead
checks
of
every year.
and or whatever?
Well.
What's the deal here?
This just means that these are dependent if you see the word then. It means that you're doing A first and then you're doing B. It really means the same as A and B, but having that word then in there kind of
I
gives you.
feel like when I say that word no, I'm just gonna notice multiply. I'm just gonna leave it at that.
All right, problem. Suppose you choose a tile at random from the tiles shown in the previous example. So look back up at your other slide. Without replacing the first tile, you select the second tile. What is the probability that you choose a dotted tile and then a dragon tile? So we already looked at dotted tile was 4 out of 15.
Yes, correct.
Now, if you already picked a dotted tile, how many tiles are left?
There is, there are 11 left.
No, we didn't pick all 4 of them. If we only picked one,
There's 14
there's
left.
14 left. How many dragon tiles are there?
There are 5, 4, 3, 2, 3.
3. 3 dragon tiles. Out of, now we only have 14 tiles. We don't have 15 anymore because this event took place. So that's what I mean by the
And then we
probability of
multiply
B
straight
after
across.
A. Yeah, but first I'm going to simplify because 3 goes into 15
5 times.
5 times.
Yeah,
And
there we
2
go.
goes into 4 twice and into 14 7 times. So now I have 2 times 1 is 2.
Which is equal to
5 times
30.
7 is 35. So the probability of that happening is 2 out of 35.
You got a T minus 10.
Okay, let's try the next one. What is the probability that you will randomly choose a flower and then without replacing the first tile, a bird? Olivia, what's the probability that you're going to choose a flower? 1 out of 15. Good. Now, if we already chose one, how many tiles are left? 14. Okay, so the next one, what's the probability that you're going to choose a bird? Julia? Out of 14. Good.
Threw my phone.
What's the same case?
I can reduce this a little bit. This becomes 1 7. 15 times 7 is 105, so the probability of that happening is really slim. It's 1 out of 105.
Do you remember?
Casey, please cut that extra stuff. And out. All right, let's look at the next one. Finding the probability of a compound event. 1 freshman, 2 sophomores, 4 juniors, and 5 seniors received top scores in the school essay contest. To choose which 2 students will read their essays at the town fair, 2 names are chosen at random from a hat. What is the probability that a junior and then a senior are chosen? So that word "and" there tells us this is not an "or" probability, it's an "and" probability.
I would
Okay,
say.
what's the probability that a junior will be chosen? Alex?
DJ, oh, junior,
Yeah, how
4
many
out of
juniors?
12.
4 out of 12, good.
Oh, you meant
4
juniors
out of
and
12.
seniors, I was like,
Now, what's the probability that a senior will be chosen? Casey?
Where's this call come from?
5 out of 12. There's 12 altogether here.
Okay, there's 12
I
altogether,
didn't
but we
see the
already
question.
picked one name, so it's not 5 out of 12, it's 5 out of 11. Good. Because after the first event, there's 1 less in the hat now, right? Because we
Respect.
threw a name out, now there's only 11 names in the hat.
Yeah.
So the chances of being selected are a little bit higher. And then reduce again, probability of this happening is 5 over 33. We have 2 more short ones to do. I want you to try the next slide, that'll be like our exit ticket. And then I will give you a worksheet that is going to be your homework. So I have
Oh,
another
you're doing a
worksheet.
worksheet.
I am.
Worksheet me.